Hello, welcome to one more class of Logistics and Distribution. Today, we'll focus on two routing exercises using heuristics. For 18, which we will compare with the optimization results that you obtained last week, and for 19, in a routing exercise with added constraints. So, let's go. So, we'll begin with exercise 418, and this time we'll use the nearest neighbor heuristic. The nearest neighbor heuristic has three steps that you will repeat until a solution is found. First, you define the beginning of the tour, and then find the nearest client. The third step is to repeat this process until a solution is found. The savings heuristic can be implemented using two algorithms, the sequential or the parallel. Let's discuss the sequential. You start by calculating savings for every pair of clients. Then you are going to rank the savings in a descending order. You start the route with the pair of clients with the highest saving, and then identify the first connection in the list that can be used for any of the arc ends. You are going to repeat this until the vehicle capacity is reached, the maximum distance is achieved, or any other criteria that you defined. If all clients are served, then you are going to stop because you have reached a solution. Otherwise, you are going to eliminate the clients already served and restart with a new route. So, how are we going to reach to our savings? We know the formula from the previous slide, and we have here our distance metrics. So let's do, for example, the savings between client 1 and client 2. If we do it like this, we have all the information needed from our distance matrix. We reached the savings for client 1 and 2, and if we do this for all the other nodes, we reach this new matrix that is the saving matrix. Here we have a new matrix, in this case our savings that are now listed from the highest saving to the lowest saving. So our algorithms say that we start the route with the pair with highest savings. In this case, it's 4, 5. So we take that out from the matrix. We identify the next connection that fits. 1, 2 is on the list. Can it be used? No, because none of the points is in route. 3, 4 can be used? Yes, because 4 is in the end of the route. Then we have a new route. We have D, 3, 4, 5, D. And we take out 3, 4 from the matrix. Now we have to identify the next connection that fits. In this case, 1, 2. Can we use it? No, none of the points is in route. 3, 5 is already in route. 2, 4, can it be used? No, because 4 is an interior point. The same thing happens with 1, 4. 2, 3, can it be used? Yes, so we have a new node in our route. And now we have to identify the next pair that it's going to fit. 1, 2 is the next one, and we see that it fits, but it's on the top, so we must not forget to always check the top of the table. And now we have reached a solution where all the nodes are visited. Now we can discuss the three methods used for a solution for exercise 418. The nearest neighbor, we got this path and the total distance of 773. The savings got us a different solution with a lowest distance. But was this the best solution we could find? No, because we also did in the last class an optimization model and we found out a different solution and with a better distance, a better solution. So imagine that we are talking about costs. We reach a solution with the lowest costs. Now we are going to discuss a new exercise, exercise 419. And what is the big difference between this exercise and 418? Is that we now have new constraints. In this case, we have the truck capacity that must not exceed 8 tons. For each vehicle, there are costs. We have a fixed cost and also a variable cost on the distance traveled. And as we have done previously using the savings heuristics, the first step is to calculate those savings. With a distance matrix, we have all the information needed to use our savings formula and compute a new matrix with all the savings between each pair of clients. But before any computing of the heuristic, we have to look at our constraints. And our constraint was that the truck capacity is 8 tons. And if we look at the demand, we have 2 clients with the demand greater than 8. So we are going to have the demand for client 2 and the demand for client 7 to have a full truckload. And that way we already have 2 routes. One route that only goes to 2 and another one that only goes to 7. And the remaining demand is going to be 175 for client 2 and 0.5 for client 7. With this, we can now get to our exercise. We have the tables with the savings listed, and the first step was to identify the biggest saving, and the biggest saving is 7.8. The next one would be 7.8.9. We couldn't use 9.10 because neither 9 or 10 was already en route. But now we have to go back and we identify 9 and 10 as the next candidate with the biggest saving. And look at the cargo we already have, 7.5. So that means that we cannot fit any more. So we have to start a new route. Now, as you do this in your piece of paper, you have to somehow identify the different routes. You can do this by using different colors, as I'm going to do, or you can use another column and you are going to state the name of that route. Here I'm going to use a different color, and if we search for the new saving that can fit, 8.10 is already included, 7.9 is already included, and if we look, it's in the middle of the first table. It's the pair between 5 and 6. So that is going to be the first pair of the second route. And now I hope that you can do this all by yourself until you reach the solution that visits every client. Now let's see how we can implement the parallel version of the savings heuristic. The preparation is all the same. We are going to calculate each savings and rank them in a descending order. The first pair to be included in the path is the one with the biggest saving. And now the difference starts. If the points are already used, we discard them. If the next pair is not fit to be added to the existing path, then we start a new route and move on to the next pair in the list. Now, we must take into consideration that it might be possible to connect clients, but also routes. we explored only one type of constraint. However, this type of problems can handle with several constraints at the same time. In question 3, not only we have a new cost formulation, but also different constraints. A hard constraint on the truck capacity and soft constraints. That means problem constraints that we would like to be true but can be neglected in this exercise with an added cost. I hope that you are able to explore these exercises and follow up with the online feedback quiz. Due to changes in Phoenix, our feedback worksheets are now going to be available in Google Classroom quizzes. Each week, we will make available here and in Phoenix a link to the questions.